Good morning to all. Today we are going to take one case study topic from Aerospace Propulsion subject. So the topic name is why aircrafts are not made beyond 1600 degree Celsius. So during the flying hours, definitely the aircraft it will be heat. So in that case, what are all the remedies and what are all the coatings are using for these cases, and these are all the cases that can be discussed with our second year students. In that students elaborately discussed about the topic.
Good morning, sir. Good morning, everyone. Myself, Avani from second year Aerospace. Today, I'm going to discuss about the topic called why the alien metals doesn't melt over beyond the melting point of the metal. As we said, the metal has a melting point of around 1350 degrees Celsius. Inside the jet engine, it crosses, it produces the heat above the melting point of 1600 degrees Celsius. It doesn't melt. What are the reasons? And what are by listing the reasons of the why doesn't it melt? First, it comes about the advanced materials. Passing to the another topic, I should speak about that advanced materials.
Good morning to everyone. I'm Combustion from second year Aerospace Department. I'm going to explain what are the advanced materials used in aircraft. Jet engines normally does not use metals like normal metals such as steel or aluminum, because using this we can't survive at the extreme heat temperature. These metals will start to bend and give damage to the jet engine. So we are using nickel-based superalloys, where the engineers decided and do maximum researches and suggested this material, where this material will extremely survive at extreme heat temperature and get damaged not easily. In turbine plates, we are using single crystal blade, which is the meaning that is single crystal block, which does not have any weakness. Because without the weakness, we don't get any grain failure. Because the grain failure is the major reason for the starting of the failure. So this avoid the grain failure. So it is very capable for extreme high temperature, and these don't get damage easily. But this is not enough. We also need plus coating and cooling, which will be explained by the next.
Good morning everyone, I'm Google, second year Aerospace Engineering. Today I'm going to share a topic under thermal barrier heating, thermal barrier cooling and coating. Even the superalloys need protection. There were chemical barrier and chemical barrier coating comes in. These were cooling barrier. These were cooling ceramic coating applied over the turbine blades. They reduce the temperature of the temperature over the metal by 100 to 300 degrees Celsius, acting like a heating shield. But the real hero for the jet engine is cooling. There are the cooling. Turbine blades are hollow. Cooling. Cold air flows in a compressor flows inside through the tiny barriers. There are few techniques which are internal channel cooling, film cooling, air forms a cold protective layer over the metal. Prevent direct contact of heat. But what if happens something goes wrong?
Hello everyone, I am Aarti and from second year Aerospace Department. To conclude, normally jet engines can operate at extremely high temperature, sometimes about 1600 degrees Celsius, because the metal does not melt because of advanced engineering and material science. Plus, jet engines use superalloys, mainly of nickel-based alloys, which can withstand high strength in heat. Second, turbine plates are coated with ceramic thermal barrier coatings, which protect the material from direct contact in heat. Third, the advanced cooling techniques like inner air cooling and foam cooling, which keeps the metal at normal temperature. So even if the metal temperature is even if the gas temperature is high, the metal temperature remains below its melting point. This shows that how aerospace engineers combine materials, aerodynamics, and design innovation to achieve safe and flight. Because of advanced engineering and design innovation, the jet engines the metal does not melt.
So from this case studies, the more amount of heat can be generated by the nozzle area, so that during the engine running time, the more amount of heat generated in combustion chamber, it will be delivered to the nozzle area. So in that case, to avoid the formation of heat using the flame cooling and using the advanced material like titanium, nickel, and in that flame cooling here we will coat the paint. So in that paint it will be coated like 1 mm or 2 mm. It can be reduce the melting during the running conditions. So that case study elaborately discussed by students. So all the type of remedies it will be explained by the students. Thank you.